going way back to do some review here of algebraic fractions. This first one was a complex fraction, which simply means fractions within a fraction. And the denominator here is a reminder that a negative exponent is a reciprocal. So I'm going to rewrite this denominator. Y to the negative 1 is 1 over y. Now, the new method of simplifying this complex fraction helps us to get rid of the denominators all in one step. So, as long as we multiply by a value that is equal to 1, we're using the identity property. So how I'm choosing this value is it is the common denominator of all 4 of these fractions. And now we just do distributive property. So when I take this term times the first fraction, notice that the x squareds will cancel. So here we will have a 2y squared left. And then we distribute times the second fraction, and notice it will be the y squareds that cancel. So we'll have a positive 1x squared. And we distribute in the denominator, and here only one of the x's cancels, so we'll get an xy squared. And we distribute to the last fraction, and we'll have a negative, and one of the y's cancel, so we'll get an x squared y. And then we look at that fraction a bit to make sure that we're finished. Perhaps we could factor and cancel, but notice this numerator is prime. There's no way to factor the numerator. The denominator, I could factor the GCF in the denominator. XY is a GCF, but it doesn't serve to help us cancel anything, so either of these last 2 steps would be okay. Our second method would be to take this same fraction and treat the numerator as one problem and the denominator as a completely separate problem. And that works out perfectly fine as well. So to get a common denominator, notice that I would multiply this fraction by y squared, and I'd multiply this fraction by x squared. Down here I'd multiply this fraction by y over y, and this fraction by x over x. So I'm treating the numerator and the denominator as if they were separate problems. So now I've got this common denominator up here, and the numerators when I add them together. And in the bottom fraction, we have xy as our common denominator. And look at what we've got in the numerators, y minus x. And now, what does this line in a fraction mean? It means division. So now I take the numerator and I multiply by the reciprocal of the denominator. And I don't think you're going to be surprised since we already did this. We're going to come up with 2y squared plus x, and our denominator is our factored form that we already saw. So this answer and this answer, of course, are exactly the same. So your choice of methods. All right. In our second question, simply a matter of remembering how to factor each of these polynomials. Here we've got a GCF of a, and I think this was my typo. This was supposed to be an a squared, sorry. And then this would be an a plus 3. And here we multiply by the reciprocal, and there's a GCF of a. And then we would have a quadratic, a squared plus 9a plus 20. And I think we can factor that as a plus 5, a plus 4. Does that work? And what used to be the numerator now is the denominator. And I can see that's an a plus 4, a minus 3. And this was kind of designed so quite a few things are going to cancel. A minus 3's, a plus 3's cancel. And this a cancels with one of those a's. So we've got an a plus 5 left in the numerator and just an a left in the denominator. Okay? So we could rewrite this as 1 plus 5 over a if you wish. But remember that you can't just cross out those a's. That would be subtraction, not division. All right, and here we've got an equation with fractions. And notice that this denominator is the product of these two. So I'm going to multiply through by x plus 2, x plus 3. So let me rewrite this in its factored form. And I think this first step, I'm going to stretch this out so I have a lot of room to write. But I kind of hope that you guys wouldn't even show this step. But to remind you that we're definitely using the multiplication property of equality. So we're going to multiply through by the common denominator since it's an equation. But we have to remember that this equation has restrictions. So remember that we have to avoid division by 0. So at the end of the problem, we can't have x equals negative 2 or x equals negative 3. All right, let's see where we have gotten here. So the reason for doing this is to cancel out our denominator. So you don't have to show this step anymore. I think you can do this canceling part in your head. Here I'm going to distribute 5 times x and 5 times 3. And here the x plus 3's cancel, so I'm going to distribute 3 times x, 3 times 2. So we've got 8x on this side. I'm going to move this x to that side right away. We've got a plus 21, so we could move it there. So we end up, sure enough, with negative 3. And your tendency might be to say you're finished, but remember you have to avoid extraneous roots. So this answer causes division by 0. So you have to remember to throw it out. So did we get any good answers here? Nope. So our answer would be null set. So we want to avoid extraneous roots. All right, so which graph has a vertical asymptote? Again, we have to avoid division by 0. Here, x equals negative 3 is a vertical asymptote. This is the equation. I'm not sure what this is the equation of. I probably didn't want 2 equal signs there. I can't cross it out. There's no division by 0 here, so this is a circle, no asymptotes. Here, can the denominator ever be equal to 0? If we tried solving this, you can see we would only get plus or minus 3i. So there are no vertical asymptotes. There are no real numbers that cause trouble. But here this factors as x plus 3, x minus 3. So here there are 2 vertical asymptotes. So A and D both have vertical asymptotes. All right, and let's do a word problem quickly here. A river has a current of 4 kilometers per hour. Find the speed of the boat. All right, so let's set up a upstream, downstream. Rate times time equals distance. So we're setting up for upstream against the river and downstream with the current. So that 4 kilometer per hour current of the water is going to speed up the boat when we're going with the current, and it's going to slow down the boat's speed when we're going upstream. Okay, there's more than one way to do this problem, but I think most of us see these distances. So when we are going 40 kilometers downstream, I think this might be what we would think of to do first. And as soon as we have 2 columns filled in, then we fill in the 3rd column by multiplying or dividing. And we can see that time is distance divided by rate. So 24 over b minus 4 and 40 over b plus 4. And notice what it says. Same time. Takes the same amount of time. So the 3rd column we fill in is always the one that we use to write our equation. So we know that these 2 times are exactly equal. This looks like a proportion, so our tendency to say cross multiply, but really we're multiplying both sides by the denominators. So 4 times 24 is 96. And negative 4 times 40 is negative 160. So it looks like we've got 16b if we go to that side, and 256, and 256 happens to be 16 squared. So the boat speed, if there were no current at all, would be 16 kilometers per hour.